Great. Well, thank you. Thank you. It's been great being here. So my name is Reinhardt Quelle. I'm an operations architect at Cisco, that name is Googleable everywhere. So I cursed my family for that name to start with, but in the Google days of Google, it works pretty well. So rquelle at just about anything, Gmail, whatever else, or rquelle at cisco.com. So let's see if we do this. So you guys all know who Cisco is. Everybody knows Cisco as the company who builds these things. Lots of big iron, lots of big things. But not my group. My group is actually an oddball within Cisco. We build SaaS applications. We're best known for WebEx, web conferencing. We also do Jabber, a thing called Cisco Social, a number of other applications. So within Cisco, we look a whole lot like the rest of you in that I look like a customer of Cisco. I buy Cisco UCS gear, I buy Cisco routers, I run in Cisco operated data centers, and I deploy applications to the market as SaaS applications. So what am I talking about DevOps today? One of the things that's useful when we talk about DevOps is to use the mnemonic CAMS, kind of popularized by Damon Edwards and John Willis of DevOps Cafe. It's a very useful tool and useful thing to think about. So what is CAMS? We've been talking a whole lot about automation, and a big part of DevOps is in fact automation. Automate all the things, and so we definitely have there's a focus and a real tendency to talk a lot about the tooling and how you do things and how we're doing things. And we kind of highlighted that this morning, in fact. But there are other parts, metrics. The M in CAMS is metrics. How are you measuring what you're doing? How do you knowing what you're doing is effective or not effective? Are you able to understand these nodes that come up in Amazon that are in fact dead nodes or really shouldn't be put in production because there's something wrong with them? Very high I/O weight, for example. How do you shoot that machine in the head before you even put it in production? So metrics becomes a really important part of automatic processes, continuous integration cycles, is how I'm measuring what I'm doing. Sharing is a huge part of DevOps. Now, what we're doing here today, talking about what we're doing, talking about what we're doing across the different groups. I was sitting there in the chair actually listening to a couple things this morning, and it occurred to me that one of the more interesting things in sharing is a lot of us are doing the same things, and a lot of us are talking back to our organizations about what we're doing and trying to explain certain concepts and certain things that are important to us. And it's been interesting listening to the way that some of the other speakers are describing things in their environment. It's like, oh, I can use that terminology. That will help explain what I'm doing. And of course, I have a terrible short-term memory, so I had to write it down, which is embarrassing. Senior moment here, but one of the things, you always have this argument about baked versus fried infrastructure. I don't know if you guys have heard that term, but one of the speakers this morning talked about looking at AMIs, at golden images, as a caching layer for your build process. Well, that explains perfectly what it's doing, and it's easy for people to understand what that means, that you cache your build process by bundling an image. And so things like that, sharing is actually very important in our world. The thing I'm going to talk today about, though, is the C in CAMS, and that's culture and specifically collaboration. And as we talk in our organizations about rolling out DevOps and talk about what DevOps is and why we're doing it, this is a huge part of making this stuff fly. And so that's the bulk of my talk will be about this. I'll touch on tooling and how we do some of these things, but the collaboration is what it's all about. So collaboration requires a number of different things. It requires, I keep forgetting that there's a slide right there. It requires shared goals. In order to collaborate, you got to know what you're trying to do together. If you don't know what you're doing together, it's hard to collaborate. The ability to communicate, to talk with each other, what I just said about being able to express concepts that everybody understands. The last one is actually what I'll talk about a lot is empathy. Understanding what your partners on the other side of the wall are doing. The operators understanding what the development process looks like, what the tooling looks like in the development community. The flip side of that is having the developers understand what is important to operations. What are the things that I think about at 4 o'clock in the morning when my pager goes off? And so empathy is a big part of this. So we all go out there and say, yeah, we're going to do DevOps. We're all going to walk and hold hands together, and it'll all be good. And so the interesting problem here is how do you get there? What does this mean? It really looks more like this. These guys sitting here, we're not actually talking together. We don't know what to say to each other. What's going on here, right? So I love this picture. Or to bring it home, none of us are leaders of nations. So the rest of us, everybody's been on a first date, right? You go on that first date, and you're sitting there at the table, and it's like, what the heck do you talk about? You have no basis for conversation. How do you understand where to start? How to actually start talking about things that are important? So of course you Google that. And it's funny, I just stumbled on this. I had to put it in. You Google holding hands. I was looking for an image of holding hands. Didn't think I'd find the president, but a wiki article on how to hold hands. Who'd have thunk it? You can find anything on the web. All sorts of DevOps stuff on the web too. But anyway, when you're communicating with these other groups, these other teams, perspective helps a lot. Understanding what the other person's perspective is, what it is how you're coming at it at each other. So I'm from an operations background. I'm the guy sitting effectively at the backside of these monitors, and so the bulk of this conversation is, what do I tell my developers? How do I have that conversation with developers about what things are important to me and what they can do to help me do that job, keep those screens green? And so it's all about keeping those screens green. Every one of those little boxes on those displays is a service. Each one of those services under the box in the middle section there represents 200 to 500 servers behind each one of those boxes. And so how do I keep those green? How do I keep them green while I am evolving the system and deploying software? And so that's what my world's about. So when we're trying to get the developers to understand what we're doing, it's like trying to help them illustrate what the world looks like to us. It looks like that if you're a rhinoceros. You have this thing in front of you all the time. So I guess technically they look outside. But anyway, what does this look like? What does operations look like? And so what I'm going to share with you the rest of this deck is actually it's an internal deck that I present to developers as they are bringing their software to operations. And I've trimmed a bunch of stuff out. Hopefully it'll still be cohesive. But it's to try to understand what this looks like. And so I go through an exercise and walk through an application. So a developer, when they're developing their software sitting on the machine, it looks like this, right? They're running a piece of code on a piece of hardware. And they're really focused on that piece of code. And they're worried about just enough stuff to get that application to run. Just the right version of the VM, just enough stuff to run. Operations, of course, when we deploy a system, we immediately do this. We got other things running on that system. I've got NTP running. I've got log rotate running. I've got all this other stuff running that has to be configured and installed. So already my scope is a little bit different from what the typical developer sees. Of course, I never run one of anything. So there isn't a single server anywhere in our environment that there's only one of them. They always run in clusters of machines. And if I've got clusters of machines, that means they have to share data somehow, either through a shared SAN or a shared database engine. A shared SAN, by the way, is a really bad idea. It's very hard to do multi-data center, very hard to run that way. Of course, it's not just the application server that you're running. There's the web tier in front of it, or the caching layers, or the administration servers, or whatever else. And of course, those have to be redundant. And so very quickly, as we deploy a simple piece of software into the ops environment for a scaled web application, we have this explosion of machines, load balancers in front of those machines, multiple data centers with GSB directing traffic between the multiple data centers, because everybody knows that Amazon East will go out sometime. Of course, everybody's piling on Amazon West at that time, so you can't get there either, but that's a different story. So being able to deploy across these multiple environments this is what the operations world looks like to us. Got to replicate the data, and oh, by the way, we have all of our monitoring, logging, billing, alerting, all those other servers that have to connect to those in those multiple data centers. So the purpose of this exercise is really, and something I go through with every development team, every new engineering team that we're bringing into operations, to say this is what our world looks like. This is why we're going to ask you about some of these things and how you're going to plug into our ecosystem so that we can effectively run your application. So I get a lot of blank looks. Many people probably heard the expression turtles all the way down. The interesting thing is when we go back to that workstation, and we look at a specific node on that workstation, you're sitting there, you've got your disk, you've got an Ethernet interface, you're starting up your application says, okay, what's my IP address, enumerates the Ethernet address, finds the IP address, starts running. Well, it doesn't work that way in operations. I've got 4 Ethernet interfaces. I've got an admin interface. I've got one for my SAN. I've got one for my, so even on the individual machine, as we go back inside, those machines are a lot more complicated than what you see on your developer's desktop. So empathy, helping the customers, my customers, effectively, who are the product teams who are trying to deliver software on my platform, how do I help them understand what it is that they're going to be running against? I talk really fast when I'm nervous and in front of people, but it's a long presentation, so it'll probably be okay. More time for questions. So bottom line is our development environment is complex, lots of nodes running lots of different services, lots of dependencies and external dependencies that we have to manage. And sequencing of everything in this complex environment is critical. You have to do things in the right order across the right machines. So you'll hear a lot about paths today, and actually, as an application developer, you say, well, I'd really rather ignore this. I'd rather ignore logging. I'd rather ignore metrics. I'd rather ignore deployment. I'd rather just say CF deploy app name. And that's a valid thing. There are many applications that will, in fact, fit in that environment, and we do, in fact, provide paths as a delivery option for some of our applications. But not all of our applications live in the paths, and that application, from an operations perspective, that operation running that, or application running that container, means I've got to install and manage that to support it. I have to install and manage DEAs. I have to manage a router. I have to manage a cloud controller, database stores, message queues, all of those to support that application running that container. So those things don't go away. They're just not as visible to the application developer. So I still have to run and manage and then live within the restrictions of the paths. And those restrictions sometimes are the right thing to do. It simplifies people's world. And so right now we have, in the current project I'm on, we have 12 major components of that application, and 2 of those deploy to the paths. By doing that, by deploying them to the paths, we shaved literally 3 months off their deployment schedule, where they didn't have to wait for any deployment, anything else. We just stood up the paths, they started deploying, and they start writing real applications and real things. But as I operationalize this, I have to bring the rest of the family in as well. So anyway, I'm not going to talk at all about building applications for distributed multi-data center operations. There's lots of information, in particular web operations by Allspa and friends, and the Release It book that was mentioned yesterday. Great reads. Hand it to your developers. Make sure they read it. Good stuff. But what I am going to talk about is this. So what is the minimum set of things that I ask an application developer to be aware of as they deploy into our environment? First thing is deciding where we're actually going to deploy that application. How do I deploy the thing, and where are the bits going to run? How do we get them there? How do I package and deliver the applications there? How are they supposed to behave once they get there? How are they going to be configured to work in this particular cluster, in this particular data center, in this particular environment? How do I manage the lifecycle of the application? Get them started and stopped in the right time. Start my database servers before I start my application, for example. How do I do health checks? How do I measure what's going on? How do I find out when something goes wrong? And finally, how do I get logs and streaming data off the system, transactional streaming data? One of the things that curls my toe is when people talk about monitoring. My system is monitored. To me, if we have to do those 4 things as a minimal set of monitoring. And so when someone says, I have a monitoring solution, I'm going to ask them, which one or which subset of those things do you do? Because my monitored application in operations has to have all 4 of those. And they all feed each other, by the way. We'll talk about that a little bit more. So this is what deploying an application into our environment means. I need this minimum set of requirements met. Where does the service run? So I'm going to breeze through these. There's the slides will be up eventually, and you can go through the slide. But one of the key things for us, a service isn't a server. We run multiple applications on a server. We run multiple servers for a service. There's lots of flexibility in how you deploy an application. The question about blue-green deployments, parallel deployments with A/B switching on the path, so you can do a rollback. There's a lot of ways to deploy an application. It's not as simple as what you might do on your desktop. A couple examples of that. One of the things that we'd like to try to reserve in operations is the choice of where I deploy an application. Sometimes it makes sense to deploy multiple instances of the application on the same host, particularly old 32-bit applications that can't use multiple cores. I've got machines sitting there with many gigabytes of RAM, multiple cores, that the applications, Rails applications, I'm looking at you, can't actually take advantage. So I deploy lots of instances of the application on that particular machine, and that's okay. But I don't do that in test or dev. I do that in integration, and I do that in perf test. But the decisions of how I deploy a particular thing, we look for flexibility on. What are my choices? What are the environments? So in order to deploy an application, I got to package it somehow. I have to get those bits onto the box. How do I get those bits on the box? There's actually lots of ways to do this. Ultimately, though, we have to say exactly what version and its dependencies are installed on a particular box, a specific box, and how is that made predictable? And all the tools that we're talking about, Ansible, Chef, Puppet, Fabric, all these tools actually help you get to that point where you're saying, I know exactly what is deployed on this box or set of things on this box. So Boy, that is really small. Oh, it's not small up there. Our distribution choices are, there's lots of ways. We also, one of the previous speakers talked about just using the OS packaging for packaging. It's very well evolved. It's been around forever. There's great tools like FPM that help you build those packages. I love FPM. Saves hours a week for me. So there's lots of, we recommend and we ask our developers to give us RPMs. Well, we actually cheat and we own the build pipeline, so we create our own RPMs, but nonetheless, RPM is our standard thing. I should note that even our Puppet, we use Puppet for configuration management. The code that is running by Puppet to define your particular system, that's code. That's software that's versioned, managed, has a life cycle. That's code too. We wrap that stuff when it's at the end of the build cycle into RPMs, and we deploy it to the systems that it's running from, just like everything else in our environment. So there are other ways to deploy software. In particular, if you're using Ruby and Capistrano, for example, you'll see things like doing Git direct checkouts. Doesn't work for us because Git's inside our firewall and our deployments are outside our firewall, so we can't actually get to our Git repos. But there's other ways, I think, is the point. You solve your problems using the tools at hand and the application that you're solving. So one thing I will note, and I kind of touched on previously, is that there are multiple units of deployment. If you're deploying to a PaaS, your unit of deployment, the thing that you're pushing is a WAR file, for example, in an overly simplistic way. If you're pushing, if you're using CloudFormation and running auto-scaling in Amazon, your unit of deployment is the AMI, and there's places in between there. So we try not to get too pedantic about what we're deploying, and they tend to be different for different applications, different environments. Wow, I'm moving along. I'm only on step number 3. I got a piece of software installed on a machine. How do I configure it? How's this specific instance in this specific environment supposed to behave? Given the fact there may be multiple instances on a particular machine, it gets kind of interesting. There's lots of tools. Puppet, in fact, one of the things Puppet is doing in our world is configuring those startup files that the application is using. And I'll have a diagram here in a minute of that. But one thing I want to highlight here is that there's a difference between, I'm out of order on the slide, but there is a difference between static and dynamic configuration. And we use both in our world. Things that I can place on a box that happen at compile time, things that happen at build of the system time, and things that happen at runtime. And each of those may have different configuration solutions. And so kind of elaborating and picking the right configuration solution for the right application. Is an important thing. One of the things that happens in our world is that when we deploy the application, we've got to unentangle what the application team thinks that they are managing versus what we think we're managing, and make sure that it's one thing that we're doing all together, because otherwise we're stepping on each other's configuration files and it gets ugly. So, ugly. There are things you can do to your application to make it more application management friendly. Be able to dump your config, be able to specify your config at the command line, be able to verify a config before you hit reload. There's lots of prior art out there. Take a look at some of the other tools and see how they do it and apply it to your applications. So remember my audience in here. I don't know how many devs, I should have asked how many devs I have in the room versus ops in the room, or how many are blended, but this is primarily talking to that dev audience. This is what you need to think about. This is where I talk about the various configurations. I'm not going to talk about this because I'm going to be short on time, but it will be in the side deck, so you can look at it and we can talk afterwards. But there's lots of different classes of configuration. We, of course, use Puppet. If you're not using configuration management, you really need to use configuration management. I don't really care which one. I've been using Chef for years. I use Puppet at work. Have used Puppet now for years. There's lightweight configuration management that you can do in your orchestration tools like Fabric and Ansible and those kinds of things. There's lots of ways to do configuration management. Pick one and use it. We actually like the ability to have a little bit of configuration management in our orchestration tools and most of our configuration management, so that if we break something in our configuration management, we can use our orchestration tools to fix it. And that actually happens every once in a while. And not all of our servers are disposable, by the way. So one thing to note on the configuration management in general is if you say, if you look at what's feeding the build of a machine, you have configuration management in the Puppet and Chef world is really around that machine specification. What is the set of recipes and cookbooks and recipes that define this machine, or manifests and modules that define this machine? Combine that with a environment-specific configuration. Hyra in Puppet's a common way to do this. Databags and Chef is a common way to do this. You take those two machines and you can create an instance of a machine as we said before, I have lots of machines. And so what defines the group of machines? And we wrap these things in a higher level definition, a cluster definition file. It says this is how this machine gets built, or this cluster gets built. What machines and what roles, and how many of them, and which data centers. And that's we put that in a cluster spec or a blueprint or a model that defines how that cluster gets built. There's actually some standards in that space. Tosca is one of them. But you also see similar things in CloudFormation and Heat if you're running in Amazon and OpenStack, respectively. I put a star there because the reality is I think most people use their own home-built little cluster management thing that they use. So the one takeaway on this thing is the only thing that changes as we move from dev to QA to integration testing to performance test to integration to US cluster versus European cluster, because we have different data privacy requirements across those two. The only thing that's changing is that environment data file. The only thing that specifies how this cluster is built differently from that cluster is that configuration file. US logs have to stay in the US, European logs have to stay in Europe, data can't cross the borders, Canadian data shouldn't go into the US. There's lots of policy things that have nothing to do with technology. So making applications configuration friendly, I seem to be a little out of order here, or am I going backwards? Maybe I'm going backwards. Or I'm looping, that's cool. Getting into this loop. It's like Groundhog Day. Talked about having the application know how to start up and restart and reread the config file. There's other things that make configuration, application configuration. You heard yesterday on Sensu. Sensu is a great example of an application that's like built with configuration management in mind, right? It's just like, it warms the cockles of an ops guy's heart to have an application like that allows us to do the deep merges on configuration files. And so thank you. Heads up to Bully to Sensu for this. Okay, so we got a cluster definition, we got files, we know we're going to deploy them. How do I make this all happen? How do I make it happen in the right time? We use tools like Fabric and Ansible and mCollective and a variety of tools to solve these problems for us. How do I start and stop services in the right sequence? How do I make sure that my machines are, when I do a blue-green deployment, when my blue environment comes up, is tested, is verified, is talking to the database, is able to take traffic before I switch the load balancer to that? These are things that are actually fit uneasily within configuration management. You can kind of force them to happen, but it's a lot easier to just wrap it in an orchestration tool that makes things happen in the right order in the right time every time. Something that can be called from Jenkins when you do the build to go push this thing. So we use orchestration tools to do this. There are lots of, as I said, there are lots of tools available. Many home built. We use an internal tool called Slim, or the Server Lifecycle Manager. We're switching over. We use primarily Fabric plus a little bit of Salt. Ansible is a great tool for a lot of these jobs. Lots of choices. Use one. Okay, I've configured my machines. I've told them to deploy. I've got them deployed in what order. Now what? Are we running? Next step is health checks for us. It's health checks and verification. How do I ensure that this server is up and running and alive? And we ask the developers to provide health check interfaces in every piece of software. If you're building a web app for me, you are going to have a /ping URL on that is going to tell me the health of your application. And not just your application, but the things that are connected to it. So that machine, anyway, it's a pretty seems kind of obvious, pretty straightforward. But like before when I was talking about, I forgot what I was talking about. Anyway, these health checks can be various depths. I mean, there's some health checks that we're running on the systems, but we're hitting them every 500 milliseconds. And there's other checks that we want to do, like a post-verification or what I call a pre-flight check on a system. It may take a long time. It may take a long time to run a full transaction through the system. And that's okay. We have both. It's like each have their purposes, and we try to be flexible on that. This is what happens at this point. We've got software deployed. We've done a little health check. We know it's running, but I have no idea what's going to happen next. I put this lone machine out in my A/B deployment. They're ready to go. It's getting a little bit of traffic. How's it going to do? What's going to happen with it? I keep going back to this one. Metrics. How do I get metrics on the system? Now, from an operations view, all I can really do for you on metrics is tell you what the health of the system is. I can tell you that things like load average and network I/O and disk I/O, but there's a whole lot more to metrics than that, and that is, how's your application doing? What is the response time on that API you're calling from a third party? How many times is your is your login interface getting hit. So there's a whole layer of application metrics that need to come from the application teams, that can't actually come from the operations teams. And so how do we talk to our peers in the development teams, we're saying, okay, what are we gonna measure? What's important to the business? How am I gonna reflect that? And what we can do in operations is provide you a place to put that. So the metrics, again, are only known to the application. Every time I have this conversation, a developer will stand up and say, what do you need me to measure? And I'm like, I don't know. You wrote the code. You tell me what you need to measure, because I don't know what's inside there. What's important to you? What's special about your application that you need to measure? Some examples of what you see on various things. This happened to be a mail application I was talking about at one time, but every application domain has its special things. And so one thing I'll say is the things that are important to you in writing the code, in testing and debugging and performance monitoring the code are going to continue to be important in operations. Like if it's interesting to you as you're contemplating how you build the system, it's going to be important to us. There's lots of ways to get metrics out of the system. You heard about New Relic earlier. We use JMX. We use StatsD, which we love. We use SNMP begrudgingly because we have a network here that only stocks SNMP. We use CollectD, Graphite. There's lots of ways to get metrics out of a box. We tend to focus on StatsD, CollectD, JMX for our Java apps. There's nothing. New Relic's the bomb. I'll say that. But it's expensive to run it at many, many thousands of machine scale. So we don't run it everywhere, but it is pretty cool for deep application metrics. Okay, got metrics coming out of the boxes. Alerts. Alerts are a separate thing. How does an application raise its hand and say, I've got a problem? Right? Now, the typical way for an application to do that is to actually not do it, to silently die, and then you try to detect from some other source that the thing just died. But we love the application to, before, well, if it does record it up, there's not much you can do about it, but if it is going to shut down, tell me you are going to shut down. If you are running out of buffer space, tell me you're running out of buffer space. How do we expose those metrics from the application and let them talk? They can be derived from other sources. We often do that, and in fact, one of your primary sources of alerts in a runtime system is thresholds in monitoring that you heard about yesterday, or events in the rest of the system. RSS feeds from your cloud provider is an alert. When I get a feed from Amazon saying I've got, what's the one that we see every week? Increased API failure rate. What the hell does that mean? It was an alert anyway. Something that will tell me that if I'm looking at the alerts that, hey, maybe when I'm deploying this application, maybe it's not my deployment tool that's crashing, maybe it's the thing I'm talking to. Anyway, there's lots of sources of alerts. They tend to feed each other. Well, I highlighted this thing at the bottom. An alert isn't an alert if it's not actionable. Otherwise, it's just data. And the thing that will tell the application, and particularly in the early parts of the development, and as long as we can possibly go, these alerts are going to go to the application teams. The alert, there's a queue. We use PagerDuty. There's a queue in PagerDuty for every application, and ops and the application team will get paged nearly simultaneously. Eduardo, if you're in the room, I'd love to talk to you about how you're doing parallel notifications in PagerDuty because it doesn't handle it very well. But there's a workaround. And so there is, basically an alert coming out of an application goes to the guy who knows how to fix it. You heard that earlier today too. But ultimately, there's things that we do triage. If 12 applications are alerting, well, it's probably an infrastructure problem, and that's an ops team's problem. But there's some nuances here. But ultimately, alerts are actionable things coming out of the system that are important. A lot of derivation here where we get alerts from other things. The last little bit of monitoring that I want to cover is logging. Logging is a rather important part of what's happening in the systems. Everybody loves and hates logs. Managing logs has gotten a whole lot easier in the last 12 to 18 months. Logstash is a wonderful tool. Logstash in particular has the ability to get data in and out of it into other systems, to see something in the event stream and raise an alert, for example, to be able to get it from 30 different inputs into the log stream. Logging is a solved problem. Don't go build your new logging system. Use that one and contribute to it if you need to. That's more for my own team, who's probably watching online. Anyway, logging is an important part of our application set, and there's no excuse not to do great logging because the tools are there now. And you don't have to pay enormous amounts of money for it anymore. I will note that there's lots of people looking at these logs. So the logs out of a system are being watched by InfoSec, by operations, by the application teams, by marketing, who are trying to understand how people are using the system. Just as you think about logging, it's a broad thing. There's lots of interesting data in there. Just some notes on logging. I won't talk about these too much other than when you're running in a clustered environment, logs take on how do I correlate stuff between machines, and tracing through becomes an interesting problem to solve. Things like tools like Zipkin from Twitter help with that, and there's some interesting cases there. So this is the response I always get. It's like the deer in the head's like, oh my God, we got to build all this stuff. It's like, how are we ever going to ship a product? And to be fair, that's, if you look at the enormity of all these things that you need to connect to, it's like, yeah, that's a lot of stuff you need to think about. Or not, because ultimately, if the application simply uses standard interfaces, and the application developer thinks about these things in this way, I provide all that. All the infrastructure that this application plugs into is there in the environment already. Statsd, I don't have to worry about standing up a stat server. I just need to send a UDP packet to a particular port and it's done. Or logging, I can just import the operations supplied log back library, and the applications will take care of logging. And so there's a lot of infrastructure that we can provide that make this whole thing easy and plug into our ecosystem. And so this is what we ask of all of our developers. Make operability kind of an integral part of developing your software. It will probably make your software development easier too, because now you've got central logs, now you've got API, metrics, you've got all this stuff that actually makes development easier as well. And then don't try to build your own HA architecture without talking to ops. There's all sorts of interesting things that happen in the network, like things break, and the data center connectivity is not line speed, and there's lots of things to think about, and I haven't even touched on that in this presentation. So that's it. And of course, yes, we are hiring. So whirlwind visit of how we talk to ops, and any questions or any time? Do I have time?
Yeah, we have time for a couple of questions, and then we're going to go into the Ignite. So if anyone who's doing an Ignite talk, probably get up here and be ready. While we're doing the questions.
I think you'll have to wait for the mic, though.
Okay. Where's the question?
So yeah, can you tell us how your Graphite server handles large amounts of UDP traffic?
The first step is
Statsd, I should say.
Yeah, so it's interesting. That's an interesting question. So we, and I'm going to talk about interfaces for a moment, because ultimately the thing that we're telling the developers is talk collectd and statsd, and what they're running in dev, QA, staging is in fact Graphite. What they're running in production is actually a different collector. It's Zirconis on the back end. So I solve that problem by saying, look, I've got a standard interface for sending these things out, and in different environments, I have different tools that scale differently, and without changing the interface in front of the customer, in front of my customers, who's those platform teams. That answer. Graphite, SSD instances are pretty nice for that kind of thing, and pricey. Actually, do you have the mic or?
Hey, so we're not quite as far along as you guys, and we're only starting to look at cluster definition blueprints. And we looked at Tosca briefly and recoiled in horror. It's a very big, complicated standard. Do you actually use it? Nope. And if so,
we're in that star category. And my cluster definition is the simplest possible, smallest JSON blob I can create that defines this thing. And most of the intelligence is, in fact, in Hira and in the Puppet modules. So it's this thin wrapper. Yeah. Same reaction. It looks a little ITIL-y, doesn't it? Yeah.
So, like you mentioned that when alert comes in, then it's got to be important to be dealt with. So I totally agree with that. But do you guys also have some like digesting system so that you look at it daily and see if anything important that you should take care of later, or forget about that? It'll come later on if it's important.
So a couple things there. The first thing is that even if an alert is not coming in at an elevated level that we have to respond to, it's still coming in. It's still in the logs. You still see the alert and the alert stream there. So the first thing is they're there. They're just not waking someone up at 4 a.m. The second thing is that the firing of an alert in itself is a metric. right? The fact that that alert is firing 50 times a day today, and tomorrow it started firing 3,000 times a day, that's going to show up on a graph, that alert was firing that number of times. And that's usually what catches our eye, is that, and not the fact that there's some stream of alert somewhere that's going into some logging system. So, anything else?
Any more questions? Anyone at the top? Okay.
Cool.
Thanks, Reinhardt.